So in 3.6, we're talking about lines in the coordinate plane. So it was kind of an extension of what we've been talking about so far. Okay. So on the middle of page 3.6 on page 190, it says forms of the equation of a line. Forms of the equation of a line, okay? And largely you guys have learned y is equal to mx plus b, or y minus y1 is equal to mx minus x1. Okay, so this is the point slope equation. I'm sorry, the slope intercept. Slope intercept. This is the slope intercept form. This is the point slope form. And you've seen both of these before. So we're in geometry. So algebra 2 and honors pre-calc, you'll be mostly dealing with this guy. But in calculus, you'll be dealing mostly with the point slope equation. And there's actually, last but not least, there's actually a third form. And it's ax plus by is equal to c. Or alternately in this form. Okay, this is called the standard form or general form. Okay, so there's 1, 2, 3 different forms. Okay, all right. So, okay, so we're good, we're good. So let's go ahead and read the that little table there on your own. Go ahead and kind of peruse it quickly and see if there are any questions. If not, let's kind of quickly go over the vertical line here. This says when x is equal to, let's see, the line says x equals 2, okay? So what does this mean? There's x equal 2. Where's the y? I mean, there's no y in this line, right? When normally we were told that this is what a line looks like. Okay, there's no y here, okay? So this kind of throws off people every once in a while. So I'm going to try to let you know what this means. So x equals 2 means that when y is equal to 1, x is equal to 2. When y is equal to 10, x is equal to 2. When y is equal to 100, x is equal to 2. In other words, no matter what y is, x is always going to be 2. So if this is 2, so when y is equal to 0, x is equal to 2. When y is equal to 5, x is equal to 2. When y is equal to negative 5, x is equal to 2. So in other words, if I connect these dots, x is always going to be 2, no matter what the y value is, okay? And that is why it is a vertical line, okay? Because again, there is no y, so regardless of y, no matter what y value is, x is always going to be 2, and therefore it's going to look like this, okay? The corresponding line would be, or the corresponding thing would be what? If I said y is equal to 5. If I says y is equal to 5, that means that when x is equal to 0, y is equal to 5. When x is equal to 5, y is equal to 5. When x is equal to 1, y is equal to 5. In other words, no matter what x is, y is always going to be 5. So if I draw a line, it's going to look like that. There's no horizontal line there, right? Okay. This is why, again, this is why when it says y is equal to 5, don't let that throw you off, okay? All it means is that regardless of what x is, y is always going to be 5, okay? All right. So you can do blah, 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 blah. Example number one. So example number one. A. Write a line with a slope 3. So slope is equal to 3, and it goes through the point 2 and 1. So well, this is just a straight putting into the point slope equation. So y minus y1 right here is equal to m times x minus x1. That's it. That's your answer. Okay. When it says to write the equation of the line, this is perfect. No, this is perfectly acceptable. Now, this is perfectly acceptable. You do not have to then from here say that this is equal to 3x minus 6, and move the 1 over and say y is equal to 3x plus, minus 5. Okay. You don't have to switch it into this form, okay? Unless I specifically ask you to put it into the slope-intercept form. Then you have to go this far. But other than that, you can just leave it like this, and this is a perfectly good answer. The reason why I let you know this is because every once in a while, you will try to, when I ask you for the equation of the line, instead of leaving like this, you're going to go, well, y is equal to 3x minus 6. Then you move the 1 over, so it's plus 1. And then you're going to write something stupid like this. You're going to make a mistake here. Okay, if you make a mistake here, I cannot give you full credit. You will lose points. And the pity of it is that you didn't have to go this far and you will lose points. You can just leave it like this. So just leave it like this, okay? All right? All right, let's do number B. B says a line through 0, 4, and -1 and 2, but it says specifically in slope-intercept form. Slope-intercept form. So I'm going to go ahead and find the slope first. y2 minus y1, x2 minus x1, so minus 2 minus 1, 2. So the slope is 2. And it goes through either one of these points, right? So there's a couple of ways to do this, okay? You can go ahead and go use the point slope and then transfer that into slope-intercept form. Or you can go, well, it's 2x, mx plus b, right? I know that n is 2. I figured that out. And then I can go ahead and put one of these points in here to find what b is, right? So when x equal to 0, y is equal to 4. So 4, 2 times 0, b. So this is 0. So I get b is equal to 4. So my final answer is going to be 4. Okay. So that's method number 1. That's method number 1. Okay. Method number 2 is that I can say, okay, I know what the slope is. Let's go ahead and use the point slope form. So I'm going to use the point slope form using this guy. Y minus y1, m x minus x1. Oops, m is 2. I know that m is 2. So I can put that in there. So what do I get? I get y is equal to 2x, not 24, 2x. Y minus 4 is equal to 2x. So I move the 4 over. Y is equal to 2x plus 4, and I get the same exact answer. Okay? Right, as I should, right? So, well, can I use this point? Sure, you could have used this point, right? But why would you choose this point over this point? Can anybody tell me? Is there an advantage of choosing the 0, 4? Holden. Holden?
Yes, there is an advantage.
Why is that?
Because it like breaks it down into two parts.
Well, it's less work, right? Because you have a zero right here, right? You don't have to do the full distributive property, or there are things that are being, so usually if there's a zero, I use one that has a zero, okay? Because it makes the work that I'm going to do more simple, okay? So just a quick note, if you have 2 points you can choose, I would rather choose the one that has zero in there, okay? All right. So that's B, let's go to C, and in C, it says the line with x-intercept 2 and a y-intercept 3 in point slope form, okay? Point slope form, so x-intercept is 2, which means that what? X-intercept happens when what? When y is equal to 0, right? So that is 2, 0. And then the y-intercept happens when x is equal to 0. So it's 0, 3. Okay, so this is the hard part of this question, is realizing the x-intercept is actually 2, 0. The y-intercept is 0, 3. Okay? So from here, we do the same thing. y2 minus y1, x2 minus x1, so that's my slope. I'm going to go ahead and put this point in. Y minus y1 is equal to negative 3 over 2, x minus 2. And they want it in point slope form, so we're done. Okay? I mean, you could do this, right? That'll be a little cleaner, okay? Because minus 0 is just 0, right? So that is the end. Okay. All right, now let's see if we can do example number 2. Example number 2, we are asked to graph a line. Okay, in example number 2, we are asked to graph y is equal to plus 3. Okay, so where's my starting point? My starting point is that when x equal to 0, y is equal to 3. In other words, my y-intercept is 3. So I know it goes to this point, right? And then I'm going to move over 2, go up 3, over 2, up 3. That's it, right? Why did I go over 2, up 3? Because the rise is 3, the run is 2. So a run is 2, up 3. 3 is the rise, right? Over 2, up 3, right? Okay. All right, now let's go ahead and see if we can do the second one. Second one is y plus 3 is equal to negative 2x minus 1. Okay, so immediately you should notice or be able to recognize this as the point slope form. In other words, they're giving you the slope, right? The slope is right here. So you're giving the slope, and it's going through a point, and the point is going to be minus 3 and 1, right? x1, x2. Okay, so how would I draw this? I would go 1 and negative 3, right? And then that's a slope of negative 2. So I would go over 1, up 2, over 1, up 2, over 1, up 2. I would just go ahead and connect those dots. Okay. All right, that's pretty simple. And then lastly, there is C where x is equal to 3. Okay, we already talked about this, x equals to 3. So this is one of those things that where regardless of whatever y is, x is always 3. So it's going to be like that. Okay. Right, so that's good. Let's go and see, there's a pairs of line thing there in the middle of page 192. Go ahead and read that for me. Again, this should be all review at this point. There shouldn't be anything that's new here. Let's go ahead and read that. Let me know if there's any questions, anything I need to explain there. Okay. Example number 3A. We have two lines. Y is equal to 2x plus 3. Y is equal to 2x minus 1. Classify the line. In other words, determine whether the lines are parallel, intersect, or coincide. So obviously the m values are the same here. So these are parallel lines. They're never going to meet. Okay. B, y is equal to 3x minus 5. Y is equal to, oops, 6x minus 2y is equal to 10. Okay, so we have to do a little work here. I don't know what y is, so let's go ahead and solve for y. We're going to move the 2y over here and the 10 over there. If I divide both sides by 2, I'm going to get y is equal to 3x minus 5, which just happens to be the exact same thing over here. So there are two identical lines that coincide right on top of each other. So one is going to be right on top of each other, right? Okay. And we have C, 3x plus 2y is equal to 7. Then we have 3y is equal to 4x plus 7. So again, let's solve for y. So on this one, I'm going to go ahead and move the 3x over. 2y is equal to 3x plus 7. Y is equal to, if I divide both sides by 2, so I get from here, I'm going to get this guy. And then from here, I'm going to go ahead and just divide by 3. Okay, so let's look at the slopes. This slope and this slope are not the same. So they're not parallel. They're not perpendicular either, right? Okay. So it looks like they're gonna go ahead and meet somewhere, and that's it, really. I don't know what else we need to know here. Lines have different slopes, so they intersect. Yeah, so they will intersect. Okay, all right. That's it. Last but not least, let's see if we can go through example number 4. Example number 4, Audrey is trying to decide between 2 health club plans. After how many months will both plans' total cost be the same? So plan A has an enrollment fee of $140 and then a monthly fee of $35. So basically I'm going to go ahead and have to pay. So this is what, plan A. So in plan A, my total cost, we call my total cost Y after X months is going to be what? I had to pay the $140 right off the bat, and then every month I'm going to pay $35, right? So, but for plan B, my total cost is going to be what? My initial enrollment fee is $60, but I'm going to pay $55 every month. Okay, right? So the question asked, what? after how many months will both plans or costs be the same? So both of these have to be equal after X months. So if I set them equal to each other, this is what I'm going to get. Move the 35 over. I'm going to move the 60 over there. 140 minus 60 is 55x minus 35x. 140 minus 60 is 80. 20x. Divide both sides by 20. X is equal to 4. So after 4 months, right? After 4 months, the total cost will be the same. All right? That's it. Okay, we're all done. Any questions?